Hello guys, so we're going to start our first lesson in 1050. These are your guiding notes with the book. So you can either watch this video or watch the Salt Lake Community College pre-videos that they made. But you have the guiding notes in front of you, and I'm going to go through this section, and when you're done you can go back onto Canvas and do your assignment. So 1.1 is the introduction to functions. So we want to look at the definition. Sorry guys, I need my highlighter. Okay, a relation is a set of order pairs. So vocab's really important when you do math because it tells you which way to go. The set of the first components of the order pairs is called the domain. So the first set, that's your x values. The second component is called the range. And of course, the second value is the y value. So I might want to write that down for me so I know later. Domain are x's, range are y's. Okay. So if we were to consider what the domain was, and I'm going to put D for domain, and I was going to put a set bracket, that's kind of like that E bracket. And as you can see, in the first of each coordinate is my domain. So 1, 2, 3, 4, and 5, and then I can end the bracket. Then we have a range. The range is at second, so 2, 4, 6, 8, 10. If you want, you can highlight them different colors, right? So I can say the domain is my first set of numbers, right? And my second set, and I can even make that a different color there, is your range. Okay. So some related vocabulary that intermixes with domain and range are input. So input, what you put into a function, that is also part of your domain. Your independent variable means that it's all right by itself. That is also your x value, your input. Your output, what comes out on the side, well, think of it. When you put x into a function, you come out with a y. So that's why the y is the output. And that is also why it's called the dependent variable, because it depends on what you're doing to your x. That's how your y changes. Okay, so that's just intermixing vocabulary for the future. So a function. A function is a relation in which two ordered pairs with the same first component also have the same second component. What we used to do when we learned this in secondary 1, 2, and 3 is we would say that for every input, there was only one output. For every x, there was only one y. And that's why if you had two of the same x's, they have to have the same y. Otherwise, it would not be a function, okay? So let's talk about this here. Is our previous relation a function? Well, first of all, did any of our x's repeat? No, they didn't. So right away, this is a function. Okay, the x did not repeat. Now we might go into a little trickiness, so watch what we're doing. Determine if the following relations represented by a set of ordered pairs are functions. Okay, so here's the first thing I'm going to do. I'm going to look at my x's. Okay, so I see my x's. I have -2, 1, 1, and 3. So right away, I see that the ones repeat. Because they have different y's, that means that this is not a function. Just remember, even though these x's repeated, if the y's were the same, which means they are in the same point, it would be a function, okay? In B, well, let's make sure we look at our x values. So -2, 1, 2, and 3. So this is a function because none of the x's repeat, okay? So order pairs are nice. Now, when you're trying to determine if an expression or an equation is a function or not, you might have to think of the graph, okay? So this right here, because we have y to the first and x to the first, no matter what, this is some sort of linear equation, okay? Let me get another pen color so you guys can see that. So something like the y-intercept's -2, so it's going to be something like this. And as you can see right here, for every x, there is only one y, okay? So yes, linear is a function. Okay, B, we have x equals y squared plus 1. Well, this is a little tricky because we know, okay, and I'm going to put this on the side. I'm going to put it right here in a side note. Okay, we know that y equals x squared plus 1, because we probably did this a lot last year, is a parabola. So it looks something like this, right? And that would definitely be a function, right? There's, for every x, there's only one y. But if you look, guys, x is not squared, it's a y squared. So actually, what that means is that that parabola is turned. So now we have an issue, right? Because let's say at this x, there are two y's. See that? So no. Now, we don't have to worry about graphing on a graphing calculator because you are not allowed a graphing calculator. So these are things, if you want to know what the graph looks like quickly, you might have to make an XY table, okay? Just like maybe here. But I'm going to show you what this graph looks like, and then we'll determine if it's a function or not. So this one kind of does a curve like that. So let's see, for every x, are there one or more y's? Every x, there is only one y, so yes, this is a function. Now, we can actually see this clearer by doing what's called the vertical line test, and that might seem familiar from like secondary 1. Okay, so what happens is you can draw a vertical line, and if your graph hits that vertical line twice or more, it's not a function. Okay, so if we look at A here, and I started just drawing vertical lines, as you can see, each of these vertical lines hits it twice. Okay, so that means this did not pass the test, so it is not a function. Here, if I start making my vertical lines, I'm only hitting the graph once as I go through my vertical lines. So yes, this is a function. Awesome, let's go to the next page. So now part of this lesson, after we find out it's a function or not, we're actually going to find out the domain and range. Now, we just found out domain and range of the order pairs. When it comes to a continuous function, meaning or it keeps going, we do an interval, okay? So the first thing we're gonna do is domain. And do you remember what values are domain? They are the x values. So if I look at my function here, I'm gonna start left. I wanna look all the way left. So if I go to the left, I see there's an arrow. So that arrow is telling me to continue left. What value is all the way left? Hopefully you said negative infinity. Now, if I go right, where is that last spot of our graph? That last spot is at 1, okay, in that hole, right? We can't say 1.9 or 0.9 because it could be 0.99, it could be 0.9999, so 1 is our best bet. Now, how do you know if it's a hole or if it's filled in? Well, that's what we use parentheses and brackets for. First of all, what's always around infinity? It's always parentheses because we can never get there, okay? And what's going to be around the 1? Well, since it's a hole and it never gets there, it is a parenthesis. Range. Range is our y value. So when you think of your y value, you want to start down and go up. So what is, if we kept going with our graph and we kept going down, you notice that that arrow makes you continue. So if we can continue all the way down, what number is all the way down? It is negative infinity. And again, we just went over infinities will have a parenthesis around it. And then if we go up, make sure you're careful because we don't stop at that 3 because see, I still have graph to go. So if I go all the way up, the last part I hit, it's hard to read that there, but it is 4. Really quickly, is it a hole there or is it continuous? It's continuous. We would see the hole if there is a hole. So since it hits 4, I think of it like hitting 4 like a wall. We do a bracket. Very good. Okay, next part of this chapter is function notation. Okay, so f of x. So we're using f of x instead of y because it allows us to do what we call evaluation. So we went from an f of x to an f of negative 1. Well, what happened here? There's no longer an x, it's a negative 1. So what that means is for every x, we're going to put in a negative 1. So I'm going to write it out. We have negative 1 squared plus 3 times negative 1 plus 4. Now, what's really important with showing your work is that if we did this calculation incorrect, you then can get at least partial credit because you show me you knew what to do, but for some reason, when you calculated it in your head or on your calculator, you didn't get the correct answer. Okay, so when we did that out, think of this. Negative 1 squared is 1, so we get negative 1 minus 3 plus 4. Oh, and what do you know? It cancels out, so the answer is 0. Next one, I'm going to write it out, right? So negative 0 squared plus 3 times 0 plus 4. Well, this one's pretty easy, right? We could have done that without doing any work. Oh, why did I put 0? That's the good thing about Zoom. You guys get all my mistakes. I can't cancel them out. 4. There we go. All right, 2. So let's plug in that 2. So negative, and then 2 squared plus 3 times 2 plus 4. That's 10 minus 4 is 6. You guys can check my work with the calculator on in your head if you want. Tell me if I did something wrong. All right, A. So remember, whatever's in here we're replacing, right? So, okay, I'm going to replace every x with an A. So negative A squared plus 3A plus 4. Now simplifying. Can we simplify anymore? We can't simplify anymore because we can't combine A squared and A. So that is our answer. All right, so that's when we're replacing the x with a value. Here, as you can see, we say f of x equals 4. So that whole thing equals 4. So instead of having f of x here, I'm going to have the value of 4. I'm going to get negative x squared plus 3x plus 4. Okay. Now, there are a couple ways to do this where we can factor, but unfortunately we have to keep in mind that there's a negative out front to, we need to pull that out. It gets a little crazy, but the easiest way in this case is we're just gonna solve, okay? So I'm gonna subtract 4 from both sides and I get 0 equals negative x squared plus 3x. Then what I'm going to do is factor out an x, because what do they have in common? They have an x. But I'm actually, in this case, going to also factor out the negative, leaving me x, and then if I'm factoring out a negative, this becomes negative. I can double check my work, because if I distribute that back in, negative x times x is negative x squared. Negative x times negative 3 is positive x squared. Okay. Now, we're saying what x's make this true? Well, if I cancel out this spot, what number in that place would make that true? Well, it would be x equals 0. Okay, so if I cross that out, what makes that statement true? X equals 3. Whew. Okay. All right, almost done, guys, for our first lesson. Determine the domain of a function from a formula. Okay, the domain of a function is the set of all input values which the function is defined. So this is where we talk about the things that that stand in our way from being a full-on continuous function, okay? So 2 things that we watch out for. Our denominator cannot equal 0, right? Because we can never divide something into nothing. So whatever x makes the denominator 0 is not part of our domain. The other thing we need to watch out for are even roots. Even roots can't have negatives under root. Okay, so the biggest example is our square root, right? We cannot take the square root of a negative number, okay? But that only happens with even. So if it's odd, we're okay. Okay? All right, so anytime you look at a function, you need to determine if one of these 2 things are in play. If they are not in play, it's automatically negative infinity to infinity. If one of them's in play, then we have to do some calculations. And we're going to do that through these examples, okay? So for A, we have f of x equals 2x cubed minus x plus 3. Well, do we have a denominator? Technically we do, but the denominator is not there, which means it's the value of 1. So we're good. And do we have an even root? Well, I don't even see a square root, cube root. I don't see the root sign at all. So we have neither one of those. So automatically negative infinity to infinity. Okay. All right. B, g of x equals x squared minus 2x plus 3 all over 2. All right. Well, I see a numerator and denominator, right? We have a denominator right here. But the thing is, Will it ever be 0? No, because it's 2. We can't just turn a 2 into 0. So that doesn't count. And do we see a root? No, we don't. So automatically negative infinity to infinity. C, h of x equals 5 over x plus 3. Oh, here we go. We see the denominator. And what can't the denominator be? The denominator can never equal 0. So what we're going to do is solve and figure out what x cannot be in our domain. So subtract 3 from both sides. So x cannot be negative 3. We are then going to write that in function notation. Okay, not function notation, interval notation. So if that's the only thing we're excluding, a normal function, continuous, would start with negative infinity and go to infinity. But we know we don't want negative 3 involved. So what we're going to do is close that there with a parenthesis because we don't want that. And then we're going to start back up at negative 3 and go to infinity. So when I write it in this form, you can see that we're not including negative 3. Remember, parentheses does not include it. It's like there's a hole there. D, I of x equals the square root of 2 minus x. Okay, denominator. Technically it's there, but it's the value of 1. I see a root. Is this an even or an odd root? Make sure you remember that this is a square root, which means this is technically a 2 there, but it doesn't have to be. So it is an even root. Even roots say what's under the root cannot be negative. So this has to be greater than or equal to 0. And then we're going to solve. So we get negative x is greater than or equal to negative 2. Then we're going to divide by negative. Uh-oh, we're dividing by a negative. Who remembers what to do? Dividing by a negative means you automatically switch the sign. So that you got to be careful. Okay, if we were to write this in interval notation, think about what this says. This says x is less than or equal to 2. So we know we have a 2, right? What numbers are less than 2? Is it going to be negative infinity or infinity? Less than would be negative infinity. Remember, we already talked about around infinities are parentheses. And because it's equal to, it's a bracket. E, r of t equals the cube root of t minus 2. So, denominator. Denominator is 1. Do we see a root? Yes, we see a root. But 3 is an odd number. Remember, odd roots are not part of our issues. So since we have no issues, it's automatically negative infinity to infinity. F, j of x equals x minus 3 all over x squared plus 2x minus 3. Okay, we do have a denominator, so we have to be careful on that. And no square roots. So we have to make sure that x squared plus 2x minus 3 cannot equal 0. So we're going to have to factor. I'm going to actually factor this pretty quick. If you know that you're still having factoring issues, we need to talk and really build that skill. But I want to do that separately and one-on-one during class. So this would give me x plus 3 times x minus 1 cannot equal 0. Okay, now there's 2 parts. So I have to ask myself, x plus 3 cannot equal 0. and x minus 1 cannot equal 0. So x cannot be -3, and it cannot be 1. Okay. All right, so be careful when this happens to be in the correct order for me, right? -3 is smaller than 1. Be careful if it's flipped, because we always start with negative infinity. And what we're going to do is go to the lowest number, which in this case is -3. Remember, we're not including it, so it's going to be a parentheses. Then we're going to start with that number, go to our next one, which in this case is 1, and then start with that one and go to infinity. Ta-da! All right, guys, so that's all you had for 1.1. So if you are all set with these notes, you may start on that section on Canvas. All right, have a good day.